Good morning, everyone. So we will continue our classes. So we will start now lesson number 5. I hope you have studied the previous lessons because they are very important, especially the last one, which was balancing redox equations or reactions. And there are 7 steps. So these 7 steps are very important. Please, I hope you have studied them very well. So let's continue. We will start now. So, as I told you before, in the previous lesson, we will take, the steps. Now we will take example on them. So here, chapter 6 from page 612, please study very well and focus with me very well because now it is very important. You have to know how to solve this sample problem. So now, sample problem A, balancing equations for redox reactions. So you see, what does he want? Write a balanced equation for the reaction shown in figure 2.1 on the previous page. A deep purple solution of potassium permanganate is titrated with a colorless solution of iron 2 sulfate and sulfuric acid. The products are iron 3 sulfate, manganese 2 sulfate, potassium sulfate, and water, all of which are colorless. So, as I told you before, step 1, write the formula equation, and don't worry, I will give you the formula, okay? So step 1 here, I will give you the formula. So write the formula equation. If it is not given in the problem, then write the ionic equation. So after we write the equation, we write what? The ionic equation. You see? So here, KMnO4, you know it is K plus, MnO4 minus. Okay? FeSO4, you know Fe2 plus, SO4 2 minus. You remember, this you should know from the study guide I gave you. Okay? Now, plus H2SO4, you know it is 2H plus SO4 2 minus. Okay? Yields, you see here, Fe2SO4, okay, by 3. So it will be what? 2Fe3 plus, okay, plus 3SO4 2 minus. You know, SO4 it's 2 minus, you know, but we have 3 of it. So we put here 3. And also here Fe we have 2. But you know, Fe, it's a transition metal, so sometimes it bonds, it has a charge of 2 plus, and sometimes it has a charge of 3 plus. Again, we continue, we continue the ions. Mn2 plus, SO4 2 plus 2K plus, you see here, plus H2O. H2O, it is liquid, we do not decompose it or dissociate it. So this is the ionic equation. So this is step 1, important. So I will give you this, you have to do this. I will give you the formula. You have to do the ionic equation. You have to write it. That you should know. Now, question number 2. Of course, each step has a mark. So if you write this formula, you get 1 mark or 2 marks. Okay? Because it's a long formula, so you may get 2 marks on it in the exam. Okay? Because it's important. If you get this wrong, then the whole question is wrong. So you should be careful. So step 2. What do we do after we write the ionic equation? It's obvious, as we learned before. We assign oxidation numbers. You see here? Okay. Then what? We delete substances containing an element that does not change oxidation state. So we assign oxidation number, and if any element does not, or any substance that has element does not change the oxidation number, we delete it. So we write the oxidation number for them. I taught you how from the 7 steps before that we took. 7 steps how to determine the oxidation numbers. It was in a figure. Please, they are so important. So you should know how to do these. So then we continue now. Step 3. Now what do we do after we wrote? Then we write the half reaction for the oxidation, and we write the half reaction for reduction, like we learned before. Then for each one of them, we balance the atom, then balance the charge. So we start with the oxidation. We write the half reaction for oxidation, this one. The Fe, look, Fe2 plus, of course, you should know. Now, we learned about oxidation and reduction, so you should know which one of them an oxidation process happened on it, and which one of them a reduction process has happened on it. So look here, Fe2 plus to Fe3 plus. Now what happened? Okay, it lost one electron. Okay, so it is oxidation, and look at the oxidation number. It has increased, so we know it is oxidation. So then, now balance the atoms. Okay, the atoms, it is already balanced. Okay, 1 Fe, 1 Fe. You see here, balance the mass or atoms. Okay, then balance the charge, easy, we write only plus 1 electron. And because it is oxidation, we put the electrons in the product side. That's it. This is easy formula for the iron, for oxidation. This is half, of course, half a reaction. Now, then we continue now. We go to the reduction. Which compound a reduction process happened on it? Here. Now you see, manganese shows a change in oxidation number. From plus 7 to plus 2, it is reduced. You see here? Now, the oxidation number has decreased, so it is reduction. You should know that. Okay? So, then, first we balance the atoms. Now, what do we do? Okay, water and hydrogen ions must be added to balance the oxygen atoms in the permanganate ion. So here you see you have no oxygen, so we have to add water. Now, how much? Because we have here 4 oxygen, so we have to add 4 water molecules. But then we have hydrogen here. When we don't have hydrogen here, so we have to add H plus ions. How much? Here you have 8 hydrogen, so you put 8 plus 8 plus 8 H plus ions. Okay, so this is important. Now, after this, now we balance the atoms. Then what do? We balance the charge. So remember, this is reduction. So the electrons will be in the reactant side. Now, how much did we know? It's easy. From plus 7 to plus 2. So how much did we gain? 5 electrons. So you write here plus 5 electrons. Then, okay, what do we do next? Okay, as we learned before, we conserve the charge. So we write electrons, the ratio of electrons lost in oxidation to the ratio of electrons gained in reduction. Okay, so it is 1 to 5. It is 1 to 5. So what do we do now? We multiply. Okay, we multiply the oxidation reaction by 5, and we multiply the reduction by 1 to balance, to conserve charge. So the number of electrons, okay, in the left equals to the number of electrons in the right. And then what? After we multiplied, okay, then we combine them. And after we combine, as we learned before, we cancel the same, compounds. So here you have 5 electrons, and that's it. Nothing else, okay? Nothing else. Be careful. Here, Fe2 plus. Here, Fe3 plus. They are not the same, so we do not cancel them. Be careful. Focus. You have to focus very well. You see here? So, here, Fe3 plus. Here, Fe2 plus. Here, MnO4 minus. Here, Mn2 plus. Okay? Here, 4H2O. Here, 8H plus. Nothing is the same. Okay? So, we continue now. Step 7, what do we do now? We combine ions to form compounds. So we combine the ions again. Before, in step 1, we wrote the ionic formula. We dissociated or decomposed. Now we, combine the ions. Okay? So, now, the iron 3 product appears in the original equation as Fe2SO4 by 3. Now, every iron 3 sulfate molecule requires 2 iron ions. Okay? So this means, you see, now therefore the entire equation must be multiplied by 2 to provide an even number of iron ions. Okay? So you should remember here, you see. So you should know, why did we multiply it by 2 here? Because every iron 3 sulfate molecule requires 2 iron atoms. Okay? So that's why we multiplied by 2. Okay, so here the whole formula multiplied by 2. So it will be here 10Fe2 plus 2MnO4 minus plus 16H plus yields 10Fe3 plus 2Mn2 plus 8H2O. Okay, you see here now. So we combine these. Do you see? We combine to get later. You will see, don't worry. Then, what do we do? The iron 2, iron 3, manganese 2, and 2 hydrogen ions in the original equation are paired with sulfate ions. Okay? Iron 2 sulfate requires 10 sulfate ions, and sulfuric acid requires 8 sulfate ions. To balance the equation, now 18 sulfate ions must be added to each side on the product side. Now, 15 of these ions form iron 3 sulfate, and 2 of them form manganese 2 sulfate. That leaves 1 sulfate ion unaccounted for. I am reading it with you step by step so you can understand. Now, the permanganate ion requires the addition of 2 potassium ions to each side. These 2 potassium ions form potassium sulfate on the product side of the reaction. So then, after we combine, you see here, so you will get, look, 10 FeSO4, okay, plus 2KMnO4 plus 8 H2SO4 yields here the completion of the formula. Okay, no need for me to read everything. So please read the steps very well, okay, and one by one you write everything, okay. Do not ignore the others, okay. Do not ignore the other ions, okay, from the beginning here. From the beginning, do not ignore them, okay? Then at the end, because you will add, you will combine again, okay? So please focus step by step. It's important. I know it is long. I know, okay, I read with you step by step, a little bit boring, but it is serious. That's why I read step by step. You have to understand, okay? So that's it. Then at the end, don't forget what? Check the balance. You will see it is correct. Check everything is balanced. So this is the end of our lesson, okay? But okay, furthermore, if you want more practice, okay, you have the practice here, okay, and you have also the section 2 formative assessment, okay, to teach you how, as I told you before many times, the formative assessment helps you prepare for the exam, okay. So this is the end of our lesson. Thank you.